Okay, so what I'm going to show you in this video is another clever mathematical changing technique, kind of like adding zero, okay? One that I showed you previously. In this case, what we're going to do is we're going to change an expression. We're just going to modify what it looks like. We want it to keep its value. We just want it to look different, okay? And the way we're going to modify it is by multiplying 1. Well, why are we going to multiply 1? Well, we already know this one. Everybody knows that if you multiply something times 1, that it equals itself. So 7 times 1 is equal to 7. We all learned this in elementary school. We've used it several times, probably in middle school. And one of the main times that we use this technique of multiplying by 1 is when we're dealing with fractions, or a better way to say fractions is rational terms, or sometimes rational expressions, okay? And so we know that anytime we multiply by 1, it doesn't change the expression, just like adding 0 doesn't change the expression. So we know that we can multiply by 1 a million times and it won't change the expression at all. It'll stay the same. So like for example, this question says, given the expression 8x over 2x minus 5, we would like to include the term 3x plus 1 as a factor in the denominator. Do this by multiplying 1. So here's what I want you to understand, is that if we take this expression 8x over 2x minus 5, if we were to multiply this by 1, it would still equal 8x over 2x minus 5. But what if we were to multiply something that is equal to 1, but it doesn't look like a 1? Well, it might change the appearance of our expression. So our expression will look different, but it won't be different. It'll have the same value. Now, I'm actually lying to you because when we do what we're about to do here, we are going to change this expression in a fundamental way, but it's not going to matter for what it is that we're doing today. So don't you worry about that, okay? All right, so here's what we want to do. We want to think about, well, we want to put 3x plus 1 into the denominator. And here's what that should look like. When we have the denominator, we have a 2x minus 5. We're going to put that inside of parentheses because we're putting 3x plus 1 as a factor. Remember, factor means multiplication. And if we're going to be multiplying, we have to be concerned about distribution. And since we're concerned about distribution and multiplication, we need these terms, because they're binomials, we need to put them into parentheses. We can't just set them next to each other without the parentheses, or it'll become confusing as to what it is that we're doing with those expressions, okay? So this is what we want the denominator to look like, okay? We want to have the 2x minus 5, that's already there, but we want it to be multiplied by 3x plus 1, okay? Now, how can I multiply by 1 and have 3x plus 1 in the denominator, okay? Well, I don't know if you remember this from elementary school, but remember that any number that is divided by its, oh, excuse me, that was a mistake, sorry about that. Any number divided by itself is equal to 1. So 7 over 7 equals 1. But it doesn't just have to be constants. It can also be variable terms. We can say that 2x divided by 2x is also equal to 1, but it doesn't have to be a single term divided by a single term. It can be a whole expression. We could have x squared minus 5x plus 3 divided by x squared minus 5x plus 3. And as long as we have the same thing in the numerator as in the denominator, it will be equal to 1. So I can multiply by this fraction right here, and it's the same thing as multiplying by 1. And again, there's a little bit of a caveat to that. It does become complicated when we start looking at the functions and the domains of these expressions, but we're not going to worry about that right now. We'll worry about that in a later unit, okay? So what we want is, we want a fraction that is equal to 1 and has 3x plus 1 in the denominator. Well, that's easy. We just need to have the same thing in the numerator. So if we had 3x plus 1 in the numerator and 3x plus 1 in the denominator, that's going to be equal to 1. And so what I'm saying is that if we were to multiply this expression, 8x over 2x minus 5, if we were to multiply that by 3x plus 1 over 3x plus 1, it's the same thing as multiplying by 1. And therefore, it'll essentially keep the expression as having the same value, okay? So let's go ahead and do this. Do we remember how to multiply a fraction times a fraction? Well, let's revisit elementary school. Let's say that there was a time when you were given the problem 2/5 times 3/7. I don't know if you remember how to do this. I hope you do. But basically with multiplication of fractions, that's the easiest thing that you can ever do with fractions. Because multiplication of fractions, all you do is multiply the numerator and then multiply the denominator all the way across, and that's your answer. 2 times 3 is 6. 5 times 7 is 35. And therefore, 2/5 times 3/7 is 6/35. Okay? So that's what we're going to do here with this problem, is we're just going to multiply straight across. We're going to do 8x times 3x plus 1. But we have to be careful here, because remember that we have to distribute the 8x over the 3x plus 1. So we're going to put the 3x plus 1 in parentheses with the 8x on the outside multiplying. Then we're going to take this 2x minus 5 and we're going to put that in parentheses. And then we're going to take the 3x plus 1 and put that in parentheses. And now all we have to do is, we just learned how to distribute. That's what we just learned how to do. And so that's what we're going to do here. We're just going to distribute. We're going to do the 8x times the 3x. That's going to be 24x squared. Then 8x times 1 will be plus 8x. That's in the numerator. Now the denominator, we're going to do 2x times 3x. That's 6x squared. Okay. Then we're going to do the 2x times the 1. Remember, every term here has to be multiplied by every term here. So the 2x also has to be multiplied by the 1. So we'll get plus 2x. Then we're going to go over to this minus 5. Negative 5 times 3x, that's minus 15x. And then lastly, we're going to take this negative 5 and multiply it by positive 1. That gives us minus 5. We're almost done. Remember that we might have like terms that we have to combine. And so we have plus 2x minus 15x. Those can be combined. And so what we're going to have here is the numerator is going to stay the same. It's going to be 24x squared plus 8x. The denominator, we only have 1x squared, or this 6x squared, 6x squared. There's only one term that has x squared in it. But we're going to combine the plus 2x and the minus 15x to get minus 13x. And then we're just going to carry down this constant of negative 5. And this is our final answer. We have multiplied 8x over 2x minus 5 times an equivalent form of 1, which is 3x plus 1 over 3x plus 1. And now we can see, because this is the product of 2x minus 5 and 3x plus 1, we have a 3x plus 1. You might say, but I don't see the 3x plus 1 in there. It is in there. We distributed it with the 2x minus 5, and so it's in there, okay? Let's do one more example just to make sure that you've got this. Okay, here we have, given the expression 4x minus 3 over 7x plus 1, we would like to include the term x squared as a factor in the denominator. Do this by multiplying 1. Why don't you pause the video and try this on your own, and then I'll do it. Okay, So we're going to take our original expression, 4x minus 3 over 7x plus 1, and we want to multiply by 1, but we want to include x squared in the denominator. Well, to equal 1, we would have to have an x squared in the numerator. X squared divided by x squared equals 1. And so this is now going to be, we're going to multiply this term times the x squared. Let's put the x squared first, and we'll put 4x minus 3 in parentheses. We'll do the same thing in the denominator. We'll put the x squared first, and then we'll put 7x plus 1 in parentheses. And so now we're going to multiply the x squared times the 4x. That gives us 4x cubed. Then we're going to do x squared times negative 3. That gives us minus 3x squared. Over. Here we're going to do x squared times 7x. That's 7x cubed. And then x squared times 1 is just plus x squared. And since there are no like terms in the numerator or the denominator that we're going to combine. Now we're not going to combine across, and we're not combining anything in the numerator with the denominator. What I mean is this expression up here in the numerator doesn't have any like terms that need to be combined, and the denominator also doesn't have any like terms. So that means that we're done. That is our final answer. Okay? All right, so if you would like another example, because this maybe wasn't enough, you could send me an email or something like that. But hopefully this is enough to help you understand how we change expressions by multiplying by 1.